welcome again. So today I'm going to explain to you how you should answer quiz chapter 4, ash and material analysis. So altogether, same like the previous quizzes. So altogether we have 3 different questions. So question number 1 to question number 3. So I'm gonna explain to you one by one how you should answer this kind of question. Okay. So question number 1, propose 3 trace elements that can be found in cereal. So for this question, you should go through my lecture notes. In there, there's a slide listing all the trace elements that can be found in different food products. So for cereal, we have 3 different trace elements actually, which includes copper, iron, and also manganese. Right, so moving on to question number 2. An oat cookie was found to contain 11.5% moisture. 5.2146 gram was put in a 28.5053 grams platinum crucible. The sample and the crucible was then placed in a muffle furnace and heated up till 600 degrees Celsius. The final weight of the crucible and ash is 28.5939 gram. Determine the percentage of ash of wet and dry bases. So how are you going to do this? We are going to do one by one. I'm going to tackle on the percentage of ash, the wet base first. So if you want to find the percentage of ash, we are going to do wet base. So what you need to do is you need to know the weight of the crucible, and then you need to minus this one weight of crucible plus ash minus the weight of crucible, and then you need to divide with the weight of crucible plus sample minus weight of crucible. All these things you need to times 100. Alright, so from the question, you need to know what is the weight of the crucible and ash. So this one, 5.2146 gram of the sample was put in a 28.5053 gram of platinum crucible. So this is your sample, this is your crucible. Alright, so what is the weight of the crucible and ash? See, the final weight of the crucible and ash is 28.5939. So weight of crucible plus ash equivalent to 28.5939. So minus the weight of crucible. So the weight of crucible is 28.5053. So 28.5053. So you need to divide with sample plus crucible. So sample plus crucible is 5.2146 plus the crucible 28.5053. So you should get 33.7199 minus the weight of the crucible should be the same, 28.5053. So all these things times 100. So therefore you will get, you just have to press your calculator, you will get the percentage of ash for wet base. Wet bases is equivalent to 1.6991%. Okay, this is the first part of the question. So the second part of the question is asked you to determine the percentage of ash but dry basis. So percentage of ash, so dry basis, okay. So for percentage of ash for dry base, you need to have mass of ash, okay, divided by the weight, original weight of sample, times 100% minus moisture percentage divided by 100%. Okay. So this one times 100. Okay. So at first, the mass of ash. What is the mass of ash? So here, the final weight of the crucible and ash. So the crucible and ash is 28.5939. So you need to minus with the mass of the crucible. So you should do what you should do is 28.5939 minus 28.5053. You should get the mass of the ash equivalent to 0.0886. Okay, and then the weight of the sample here given to you, weight of the sample is 5.2146. 5.2146. Okay, so 5.2146 times, so you need to do the 100% minus the moisture percent. What is the moisture percent? 11.5% moisture. So 11.5 divided by 100, right? So this one, all these things later on you need to times 100%. So from there, what you will find is percentage of ash. So this is dry basis, right? Is equivalent to 0.0886 divided by 4.6149 as 100%. Okay, so you have to press your calculator. You should get the percentage of ash, the dry basis, equivalent to 1.9198%. So this is your final answer. So altogether you have two different answers. So if it's for the wet base, the percentage is 1.6991%. And if it's a dry base, the dry base you should get 1.9198%. Okay. Okay, we're going to move on to the last question for this quiz. Briefly explain how does the concentration of trace element in cookie sample analyzed can be determined. So how you could determine the concentration of the trace element. So the first thing first, you need to tell me what is the suitable instrument that you can use. So in this case, the concentration of the trace element in cookie sample can be determined by using the atomic absorption spectroscopy or the AAS. So how are you going to, because you were asked to explain briefly on how this concentration can be determined. So you need to tell that the cookie need to be digested first. So the digesting method that is suitable for AAS is actually the wet digestion, and that means that the cookie need to be digested using the wet digestion prior analyzing with the AAS. And then because you were asked to explain, right? So you need to explain in detail, although not too detailed, just briefly. So after the compound has been atomized, when this one after digestion, you need to put the sample in the AAS, right? And then the compound will be atomized by the flame, and then the radiation source, which is the lamp, will pass through the substance. So will pass through your sample. So the concentration of the element in the sample is determined by measuring the absorption of the electromagnetic radiation by the atomic vapor of the elements generated by the sample. So the sample is being sucked through the AAS, and then from the sample it will have the flame. So from the flame, the light source will pass through the flame, and the sample in the flame will absorb some electromagnetic radiation. So the amount of the radiation from the light source absorbed by the sample should be proportional to the element concentration. So that is how you could determine the concentration of this trace element by using the AAS. So that's it for now. I've already explained to you how to answer question number 1 till question number 3. This is the end of the tutorial or discussion for your quiz chapter 4. I hope you can subscribe and press the like button. So I'm going to see you again during the test. Should you have any question, please drop your comments below, and thank you very much.